Hi guys, welcome back to another inequalities session. So we'll continue it today. In fact, inequalities and absolute values. And today we're going to talk about the must be true questions. More specifically those which get really complicated where we have those multiple inequalities and then we have to see what is given and what is it that must be true, etc. Right? So those get a little confusing. So we're going to take a look at some of those questions in detail. We'll start out with a relatively simpler question and then we'll go on to those questions. Yeah. So I hope you have reviewed your absolute values as well, because we're going to use those also. And I hope you've reviewed the basics of must be true as well, because it'll help you follow what is going on today in these slightly harder, slightly trickier questions. Yeah. At the end of the session today, I also want to talk to you about a couple of things. One, I want to talk about section tests that we have recently introduced. And I also want to talk about the favorite feature, because it seems that quite a few of you are not sure how to use it, etc. So I will talk a little about that at the end of the session. First of all, let's start with our inequalities and absolute values in must be true questions. Yeah. Give me a moment. I'll just share my screen. So if 2 is less than, I know how to deal with a constant, right? Over here, I can easily multiply both sides by 4. I know it's a positive number, so nothing will change. So what do I get over here? I get 8 less than 9 minus x, right? I've multiplied both sides by 4, or I've basically taken 4 on the other side. And now I'll take x over here and I'll take over here the 8 over here. I'll get x is less than 1. Yeah. So guys, now we come to one of the really these are the tricky kind of questions that I was talking about. When I say must be true inequalities, this is what normally we struggle with. Yeah. If and whatever is given to you, which means that this is what is given to us, right? As we discussed in our previous webinar also, the most important thing is what is given to us. What is given to me? That x will take values which are less than 1. So I have my 1 over here, I have my 0 over here. It's just easy. Always, for reference sake, just putting down 0. I know that my x is less than 1. So x takes all these values. Yeah. All these values. So x could be this, x could be this, x could be just on the left of 1, x could be here, whatever. But all these values x takes. These are the values which x will take. X, yeah, this is given to me that x is less than 1. All right, which of the following must also be true? Now, first one, it says x is less than 4. So x is less than 4, yeah? If I put it on my number line, what does it look like? And I'm going to put it on the same number line, yeah? Let's say here. So my 4 is, let's say, somewhere over here. So x is less than 4 looks like this, yeah? Now, guys, think about it in this way, that what are the values that x can take? You might get confused now over here. Okay, so then x can be 2 or x can be 3 as well, etc., right? No. What are the values that x can take? X can take the values that are given to us. We are given that x is less than 1. So then I know that x is going to take either this value or this value or this value. Yeah, now think about it. That do all these values satisfy x less than 4? In each one of these cases, is x less than 4? Let me see. Yes, it satisfies, right? Let's say x is half over here. It is less than 4. Here, again, it is less than 4. Here, again, it is less than 4. So the range that I need, that my x should be less than 1, that entire range, this entire range to the left, this is covered by x less than 4. Even if there are some extra values here, 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 which do not belong to my range, they are absolutely irrelevant to me. I don't have to worry about that. I have to see what are the values that x can take. Can I say x can take a value of 2? No, because I'm not given that x can take a value of 2. I am given that x must be less than 1. So the value that x can take, they are half, for example, they are 0. Now, for example, -1, or let's say -10. These are the values that x can take. Now, for all these values, is it true that x is less than 4? It is. Yeah, this statement of mine, it does cover all the possible values of x, and all the possible values of x are just these ones, right? And this statement, it covers all of it. There's some other regions also that it covers, but that is absolutely irrelevant to me. I don't care about that. As long as it covers the values of x that are useful to me, that are of interest to me. Yeah. So since all of these are covered, so that is the reason why I say that yes, this is also true, because this is going to hold for every value that x can take. Which are the values that x can take? It can take half, it can take 0, it can take -1, it can take -1002, it can, whatever, these are the values, right? And for each one of these values, x will remain less than 4. And that is why this must be true. My x can take only these values. And it works for all the values, all these values that x can take. Yeah. All right. Let's take a look at the other one. Minus of x minus 1 is positive. Now, is this true? That this is true. If I look at this, what is this? This is x is less than 1, right? Minus x over here, I take it to the other side. Here, this becomes plus 1. So I get x less than 1. So x less than 1, what range is that? That is, of course, this entire range. Anyway, I have been given that my x is less than 1. These are the values, which have been given. And for all these values, let's say for half and for 0 and for -1 and for -1002, x will remain less than 1. Yeah. So, of course, it works as well. This is also necessarily true for all my values which are a possible value of x, and of course infinite values more, all of them are going to be less than 1. So this is also correct. Yeah. Okay, now I come to my mod. Please think about it in terms of distance. It will make our life really, really simple. What does this mean? X mod of x plus 2 is greater than 1. It means that the distance of the point x from -2 is more than 1. Yeah, so if I were to draw it on the number line, I would say this is -2. The distance of the point x is, this is my -1, it'll lie over here, and this is my -3, so it'll lie over here, right? All right, if I'm going to, I go back to my original number line, from, how do I plot this thing now? Is greater than 1. Where are these points now? So -1 is, let's say, somewhere over here. This is my -1. So I'm given that all these points work. And I'm given that over here, let's say I have a -3. This is my -1, and all these points work. Yeah. Now, for all my values of x, is this true? Does it cover my entire given region of x? My given region of x is this entire region. Does it cover the entire region? No, it does not. It does not cover this in between the -1 to -3 region. These points are not covered. What does that mean? It means that x is -2 is also possible over here, right? Given it is given to me that x can take a value of -2 also, right? Any value less than 1. Yeah. If I put a -2 over here, what do I get? I get -2 plus 2, which is a 0. I get 0 greater than 1, which does not hold. This is not valid for -2. And that is why there is a break over here, right? For these points, this relation is not valid. This relation is valid only for these points and for these points, which means that there are some points for which this is not true. X can, what value can x take? X can take half, fine, it works. But x can take -2 also, in which it does not work. So that means this will not always be true. It could be true, but it will not always be true. It's not necessarily true, right? And that is why this is not necessarily true. My 1 and 2 are necessarily true. Is this okay?